So, yeah, thank you for everybody coming today. We are going to be presenting about the design system at the Trade Republic. It's going to be about how we develop our new design system and the automation tools that we have used in order to make the process much more better to hold, not do the manual stuff that you maybe encourage during the development and many parts related to the design. And here, yeah, we're going to be presented together with Ahmed and me, Zhanibek. Yeah, my name is Zhanibek Marshal. I'm working at the Czech Republic, and then, yeah.
Hi, I'm Ahmed. I'm also working with the Republic as an engineer. I'm from Egypt, so I hope you like the talk.
Yeah. So, those are the topics that we're going to be covering today. Yeah, at the end, we're going to be, if I have time, the QA also is possible. And in any case, we have a booth there, at the stands there. Yeah, please come and visit us to also discuss. So yeah, let's go. And also, if you have any questions during this presentation, please put it in the Slido. Yeah, we will try to also answer that later or during the Q&A. So yeah, let's talk about the design system. So basically, as we could understand, from the 2.0, we've been working creating the new design system from the big existing design system that we had, that legacy it's called. But how it started at the beginning is that we have started foundation of the design system first version back in 2 years ago. We had basically started to gathering all the components that we have in our application and try to just collect them and create the design system. So at the time we had heard that the Jetpack Compose gonna be out and if at that time it was still the beta version, but we have invested our time to look at it and try to integrate into our first version of the design system. So from the beginning we had already the Jetpack Compose, but not fully 100%, just many new components that been rewriting the components. But still we had many fragments or old custom views and so on. So yeah, it paid off a lot. So from the learning from the first version of the design system using the Jetpack Compose, we have created a new design system based on the learning from the first version. So then we launched the first version last year, in the beginning, February. And yeah, it's basically how the current applications looks like. You can start working, investing, and buy the stocks, ETF, derivatives, and many kind of instruments. And yeah, we are basically the neo brokers that lets you user to easily buy the stocks, whatever, and make investments democratize the wealth and so on. One thing that is to just collect all the components that exist across the project. But we wanted to have a more clear vision for how the design system should look like, because designers have their understanding what could be best for the product to grow further, and we have been discussing with the designers we started to collect our new vision at the mid of the last year. Then we started to create the foundation for the new beginning of the design system. So we finished all the basic components works in the winter, December. Then I started to work on integrating this into our application for the production. So then finished up the design system just recently. So now we have a new design system working on our application, and we want to share about what during this time we have experienced, the tools that we have used. So this is how they look like in the new design, which we can see that it's very colorful, it's have a dynamic colors support, and then there is a more nice feeling of the navigating across the application. So we focus a lot on that, to have many nice animations, and then it's by using the new design system, it helps us a lot to make this reshape our application. So yeah, now we are at the DroidCon to share our experience. So yeah, so about the foundation of the design system, Ahmed can be talking next.
Thank you. So before discussing about the tools that we have, we wanted to share with you about what is a design system, what makes a design system a design system, what is a foundation. So I hope that most of you has idea about a design system, but basically it is quite like a collection of components that we have. And in 3D Republic, we are using the atomic design methodology, which basically is kind of inspired from the chemical fields, which everything starts from a smaller bit. So start with atoms, atoms create a molecule, and then organism, and then you create a template and page. And this is basically how, like literally every screen or every application works, regardless if you're using atomic design or not. So starting from like the smallest bit of the apps that you have, you can see that we are using this as a check mark. And check mark cannot be used on its own, so that's why it's called the atom. This is a smallest bit of any kind of component that we have. Then this is basically when we try to create a molecule, which is a combination of atoms that can create small functional components. This is kind of like a list, which has an icon, a text, and a check mark. Then in the second part, we have organism, which basically can be like a collection of molecules or components or an atoms. So this can be done. This is a filter screen that we have. And then a template, it's basically something that's being recommended. If you see something that's being reused or redundant in your code, it's much better to extract the logic and make as much as abstraction as you can. You create a template. And basically a template can expect like whatever it has and also the action out of it. Then once we create or finish the templates, you start creating the pages. And the pages is basically something that you can either you reuse in the app or can be unique. So this is a filter screen. It is being used in multiple screens that we have. And then the next part is basically when it's coming interesting. So what makes a design system a design system? It's basically every bit of the app or every bit of the component that we have, it is a design system. So we're starting with the foundation. And the foundation is basically something that might change or might be changed, but should be from the first. And when it changes in one place, it should affect all the other places that we have. So this is like a definition of design system that I added. But like we started from here from the basic foundation, the colors. So when you start building a design system, what happens is like you're creating a UI pattern, and UI pattern is basically your branding colors or whatever colors are theming colors that you have. So you're starting adding the colors there. And then you're starting using typography because you need to have the same font, same style all over the app. So basically you need to have it in a common place in the design system. And then the shape of the icons. Why I added this 3 things or like 4 things as a component, because these things can be, it should be auto-generated in a way. Once we create it once and we want to change it, it should be one place to be changed. So I added also component today because I saw a talk yesterday talking about how to auto-generate component as well. I will not cover it, but I will just mention it. So, and also theming, spacing can also be, is part of the foundation itself. So this talk now, or this is like the second part, is what should tools that we have. So let's say all of us is using Figma or Zeppelin, which basically is the same place that everyone uses. So I'm going to cover today Figma because this is what we use. So first of all, whenever we create any design system or any things, you should have one source of truth, right? You should have one place which contains all the data also that you have. It's have multiple reasons why should we do this, for consistency, efficiency, scalability, collaboration, communication, etc., etc. But at least you need to put it one place that if a designer asks me to do something, I will not go to the designer and say what change. I just go to one place, see that new changes, and apply it, right? And we are using Figma for this. And for us, we basically like adding all the foundations that we had in Figma. So we have like the icons had its own file, the typography had its own file, colors had its own file, design system which have the components had its own file, etc. And also everyone using Figma for other like screens or features. So I will not cover this today. So I will start with some kind of horrible story somehow, or some pains that we're all facing. So we have an icon kit, right? And I added all the icon kits in the app. And so let's say we started with 10 icons, exported all of them, added to the app, And then the designer said, okay, I want to use this change. Later, the designer want to change only this icon. So I go to export icon, download the icon, go to Android Studio, export the icon as a SVG, then it will return as an XML file, right? So it's very kind of straightforward, very manual tool that we should have. Then the next time, the designer came and said, like, yeah, we did change all these 7 icons or 8 icons. It's doable. It's redundant work. It's doable. It will take more time. It's okay. It's doable. No one gonna say no. Then the next time, designer 2 or 3 icons. Okay, do you know which icons that changed? No. Do we Figma have history? No. So you either have 2 options. Play a guess game, see, check it out how it works, or just like remove all the icons that you have and download it again, which will take a lifetime. Then this is basically every time that we should see change with the designers, or it's because they're very innovative and they change a lot. So we decided, okay, we need to find a way to do it. Okay, so we're gonna go to Figma and see what is Figma having. Sorry, oh, that was not. So Figma has an API, which basically you can go there, you create your own script, getting the data, and this is how the script looks like, right? There is component, document, children, versioning, or whatever, but it's quite hassle. It's like we already have our own hustle with our own API, but I'm not sure we're gonna do it with Figma as well. But, and then you're gonna say, okay, and we're gonna do it. But like Figma have multiple naming conventions that you need to know, right? So we have on the left, we have the pages, and this is called document, and the document has a canvas or a file, which basically have its own icon on the top left here. So, okay, we're gonna follow the Figma tooling, but it's quite hard to parse the data and getting the data. But because also, like let's say, you did the parsing, you did everything, but Figma still cannot add XMLs, right? It added like SVG or BNG, and then you need to do the conversion on yourself. So we had our time and we had our search, and we said, no, we should not do this. Luckily, we find a tool which doing this out of the box called Figma Export from RedMad Robot, which is basically a command line utility tool, which can export colors, typography, icons, images from Figma to work with Xcode and work with Android Studio as well. So this is a tool. It's super awesome. So I encourage you all go there to start it, and kudos for the people who did it. And then the setup. So it's very straightforward. You pre-install the tooling, and then you export your Figma personal token, which is super straightforward according to Figma documentation. And then this is halfway there. So now you have the tool set up on your machine, but it's not working on your application yet. You need to add more configuration. So they provide YAML class, which is not great, but at least it's YAML. And you need to provide a couple of data. You need to, So you need to provide like some ID and some icon, like naming for the Figma frame, and where this should be go, and basically some templates if you want. So I'm gonna go through one by one. So the first Figma, or the Figma file ID, which is, you can find it inside the URL. It's next to the file, and this is where you have it. And the icon kit is the name of the folder, if you can call it a folder. Next thing, you have the icon, which basically is a frame name, which is you are interesting to do. It can be icons, or it can be colors, or whatever, but at least you need to make it sure it's adding the configuration code. Second thing is like you have some optional value, which I really like about this tool. It's basically, you either go with templates that they provide, which auto-generates the code for you, or you create your own template. And they provide something called Stencil. I believe this is kind of like a Swift library, where you provide how the auto-generated code should look like. Because this is a file, you need to provide the import that is going to be needed later, the icons that you have, and whatever helper methods that we have. We are using a gallery, so we have our helper here. Then this is how the generated code look like, right? Because we had it here with the icons, inside the object, and then you will find it inside the object with the name and with the resource file that you provided. And then also all these things auto-generated, so it's working great. Then you have to do one last thing. Just run the script, as easy as it is. This is like just running the script and it works for you. You either want to have it in CI or you do it locally, it works. So you have this like ton of icons, and it's imported all the icons in your code base to the code base based on the latest version. Then, like once you finish with icons, you can do the same thing with colors, typography, and image as well. So it's very straightforward to do. So, but one last thing before finishing this section is this is an auto-generated code, which means that it's remove all the files from the resource folder that you have. So it is recommended. It's very, very recommended to create your own module, which is an auto-generated module, which basically the only responsibility is getting the responsible like downloaded or generated icons or colors and being there, and then you use it to Gradle. And yeah, so this is, and now Zhanibek is going to talk about lens check.
Can you take the timer? Yeah, so that was about the Figma exports. Yeah, basically resources. Now we start to work on writing the actual developer codes, like into your project. So we have all the resources, but now whenever developers start to working on the actual design system component implementations, then you actually have like a kind of maybe standards convention between your teams, like how your code should look like, and so on. So LintCheck does this analysis and try to ensure that you don't break the your same convention that you write for the code. Because it takes a lot of time to just look at the codes during the pull request. So what we have done is that we tried our Android guild to discuss about how we want to shoot the code for the Jetpack Compose in general should look like, and we decided that we're gonna be following the Jetpack's common convention that we available on the GitHub repository from the Google. So we have extended those do's and don'ts for the Jetpack Compose. And nice thing is that Twitter have open sourced their convention for the Jetpack Compose rules, and they got the adapter for the text. And we have been using this to analyze the codes for the design system, and it does work great. And we have additional configurations which checks the some common convention for the modifiers or the naming and many stuffs. We had additionally, of course, the legacy design systems, so we have applied the exclusion of some of them because it's gonna be breaking because we didn't want to touch all the legacies. So you will need to have some configuration, of course. But also having the standard conversion is nice, but it's nice to have your own rule so that you rule it yourselves at your organization. So this is a small guide how to write your own rule. There was, of course, other speakers who have shared their learnings from how to write the rules, but this is our how we did to simply created that. So we wanted to have create a new design, a screen. Then don't use the same design system from the legacy and the new version of the design system. So we applied this custom rule that checks that there's no more imports other than one the one real design system that we want to use. So we have extended the tech rules and then applied the logic to check that there shouldn't be imports more than one. But if there's the text that there is 2 imports for the design system imports, then it's gonna be wording that it shouldn't be. And then during the PR checks, it's gonna be failing that there's this kind of rule that you apply within your team. So having this kind of rule for your design system team that works on is very nice, and it's a base ground for the startup writing the code actual. And also, after writing the rules, it's also nice to have a test that you verify that this is all good. And here is the example how it shouldn't be when you have a legacy, and then the MLP how we called the new design system. So in this case, the rule should be failing, and having the test is always the must go. And please it's much more safer and ensure that you don't break your rule as well. And then you just edit this rule into your text configuration, and that's all. So we have like a somewhat several rules that we have, and yeah, it's working great to like check the design system's code, and then like don't worry about like checking during the pull request that we follow the same convention across the team. So now it's about the next section for checking the actual design system component that we have implemented, because after writing it, yeah, so developer might run this design system components on their physical device or as their emulator. That's one thing, but it will be nice if you can verify that on the CI as well. So snapshot testing is must go for design system implementation. And during the implementation of our second version of the design system, we had integrated the snapshot testing using the paparazzi from the company blog. It's a very nice tool because it lets you run the snapshots without having to using the real physical device attached to your CI, for example, and it's running on the JVM. So it's basically you write the unit test for which is basically recording your design system component, and it takes very fast. So just basically running the one test, it requires a few milliseconds. And yeah, of course, the startup might be a bit slow, like about maybe a few seconds, but then afterwards we have thousands of the tests for the design system components. It worked very great, and we have also like a standard for writing the snapshot test at the Republic. Yeah, so yeah, we just extend the snapshot test class, abstract class, then run it, writing by inside the test, like actually what you want. And yeah, so there's out-of-the-box support from the paparazzi to put your Jetpack Compose code, basically our design system, and yeah, put all the various states for your component, and it will generate you like the result for the snapshot. And this was like our real experience while writing the design system, that somebody noticed that in some other languages, component had the requirement that the maximum length for this text, and here it's saying that the I is like a trim it and whites it. Well, basically we know that it might be some specification from the component, and we might have to update it. But first, instead of just fixing immediately, I tried to write a test to verify that this behavior is reproducible on component itself by writing the snapshot test. So this is what the test looked like for this button component that we had. And so basically you put all the states that you require. So I put this text that the Italian language for the invest is not invest, the transfer C. So yeah, after putting this all the tests, I generate the recordings for the snapshot, and as you can see that the result was a failure because yeah, it's reproducible, so we need to fix this back. So we have a various kind of like a condition for the snapshots, like a small default size, small, dark theme support, like and also dynamic color that we have added as a new feature. And yeah, I dig it up and find the bug actually where it is. It's not a bug actually, but it's how the components works. But yeah, we have discussed with the designer that we need to update the configuration, like specification for this component. And after discussing it, yeah, we have removed this requirement for the component. After fixing it, you regenerate the snapshots. You see that the result is all good. Then yeah, after updating the component, I saw that some other place it's breaking this buttons on the menu, like that. It should have been like have an icon, but now that we have updated the configuration, it's a break that the icon is not visible anymore on that component. So you might encourage this kind of things, and snapshots helps you to verify that everything is okay. And for our pull request, we record this new snapshots and check that we have a new snapshot recordings after changing the design system module, and it opens a new pull request, and like on the new pull request, you can find that like what was the change. If you think that that's all good, then you merge into your source of the pull request, and now the engineer doesn't have to worry about creating the new recordings on their local machine, and and it's where it works well, and it helped a lot for the design system work for the new version. Yeah, so I'm heading to the next.
So after creating the components and make sure that CI works and stuff, it comes to the second stage with, okay, who is going to test it and who's going to use this component, how we should test it. So the question is, should the user, or like should the people who tested going to the app and check out every variant with every use case and edge case or not? No. So we decided to create a design system gallery app, and the target audience is us as engineers and QA people as well. QA people can be designers, can be product, can be testers, can be anyone, right? So we need some place to have all the collection of components that we have for testing and also for our toolset. So we start from the beginning for our app. So starting from the CD part. So we need always to have a continuous deployment, right? Having the latest version is being created and being deployed to our internal use. So we have our own action, GitHub action, which is creating our APKs, which added to Firebase is our users app that we tested. And then you install the app. So the internal app, or like the debug app, has two actions, not action, home screens icons. One for the action app and one for the developer toolings that we have, which it should only have it should show in debug only. Then you open it, you will have a design system gallery, and this is how it looks like. So it has all the components that we have. It's filterable. It has the variants. It has like every bit of let's say configuration for that this component can have. So it's really good to have such a setup in your workplace, just to make sure that you are fully having all the use cases. And then this is how it works, right? So we decided to have the gallery, and we decided to make sure that we go through the code and edit every component, right? So each component should have its own content screen, and it's a composable function where you have the dynamic screen column and the settings, and I will talk about settings later. So we created our own helper method to have the component as lambda, and we added the check mark here as we saw before. And yeah, as easy as is, and this is how we should use it inside the app, right? So it's kind of like fulfilling the two things that we need. Designers gonna see it in the gallery app, and also us as an engineers know how to use this component. It's just a sample app. And then we have the settings, and the settings can be the variants, right? So we also creating our whole helper method, which adding the states, the variants inside the gallery app. And then we have our own kind of like global or generic settings, which should how the background should look, if should we show the layout bounds, etc. So it's very handy tools that we should have it. And then this is coming to the most interesting part for us, as from the automation point of view, right? So you have two options. You can create a list of compositional function, and you add each time that you create a new component, create the same function. Then you pass a function to this list, or you can use the annotation for it, right? So for the annotation, we decided to go with KSP because it's faster. And why should we use Capture anymore? Because KSP is much faster. So KSP, in a nutshell, is basically a Gradle compiler, like Kotlin Gradle compiler, which provided by Kotlin, which help you to create some annotation and then process this annotation later on to have it in your app. So this is how it works. So you create an annotation class where you basically need to define what is the optional and what is the thing that you need. So the section is being defined. So a section is either it's a atom, molecule, or a template, or a pattern, right? So you need to define it. And then the ID that's going to be used in the lazy column later, and then the title that you want to see. And the show toolbar is an additional configuration that if you want to add it or not, right? And you create your own processor. The processor works going through the whole annotation inside the app and try to add it to some auto-generated function. And this is basically the same old setup that we had in the design system point one, which every time we go to the same gallery screen and we just edit the icons there. It's becoming a very huge file, and using the annotation processing helps a lot because you don't need to touch this file anymore. Then this is how it looks, right? So the section is basically defining the section is an atom and the check mark as a title. And basically this is, you can use this list to your inside your setup to iterate over it and create the section and the foundation as you wish. So this is basically it for our tooling. So a summary of what we did from the design system 1.0, which was experimental when we use Compose in beta, and now it's becoming more mature, where we have more auto generation, more kind of like we fix all the things that we hate, right? Like I don't need to like go one by one to the atoms. I can filter it with a search, which we add, and then the automation. We didn't have any screenshot testing, which is a nice addition. So, and then we have this like automation tools, which Zhanibek can talk about.
So yeah, basically all the tools that we have used is in order to make us progress into making more better process, like writing the design systems. And yeah, all the topic that we have discussed, we were based on those tools that we have used. The Figma export in order to get all the Figma foundations, color, like resources, like a typography, everything was exported from the Figma using this tool. It's a such nice thing that we had able to edit from the beginning. And yeah, it's basically whenever their designers have requested, we have updated the script. Run the script and like get all the updates. Then Twitter compose rule was like basically having all the static analysis code with the common JPEG compose and applying our own rule as well and using the detect. So yeah, it helps for the team of large inside a large organization where there's many Android developers working together. In this case, having the static analysis tool is a must-have. And yeah, to implement the design system, it does help to check that everything is okay. And the KSP, to what Ahmed has shared, like a last part of the section, that creating the gallery app is very straightforward by using the KSP. Of course, there's tools available on the open source as well from the Airbnb showcase, for example, which is using all the annotation of the previews, then gather all those previews, and it creates you the separate applications same way as we do. But we wanted to have more our own customization in order to make designers much more menu state configurations and have applying their own rules more easily. And yeah, it could be very nice if you have such kind of tools at the organization. And this was a very nice one of the tools that we have used. And one more thing, that the paparazzi, it's verified the result of the components implementation, and you seeing visually what's changed, and you don't have to run all the stuff in a physical device to get the new results. So after creating the components, you run the paparazzi, then get the result of the snapshot, check that it's all good, and updating it after finding the bugs is also a very nice way to run the test. So yeah. Those were our findings from the implementing the design system. So if you have any more comments, please you can ask in the Slido as well, and then here in the microphone in front of us. Last 5 minutes. I think that's a perfect timing, right? So thank you.